Back, scholars, to another video. So today, thoughtful mathematicians are going to compare fractions and whole numbers on the number line by reasoning about their distance from zero. So essentially, we're going to use our number line and determining how large or small they are, comparing them to zero to be able to compare these fractions. So once again, we've seen these vocabulary words now for a few days. Go ahead and pause, read them to yourself, and press play when you're ready. Pause again and read them to yourself. Press play when you're ready. Let's get into our lesson. So we want to place the two fractions on the number line, then compare using the less than, the greater than, less than, or equal to symbols. So I have my number line from 0 to 1. This is a whole. I want to place 1/3 and 2/3. So since they have the same denominator, I'm just going to split it into thirds. And I want to place 1/3 and then 2/3 on my number line. So 1/3 would go right here. And then 2/3 would go right here. And my whole would be 3/3. So I can go ahead and write that up here just for as a reference point. Let me label 2/3 in a different color actually. 2/3. Okay. So now I'm going to look at these two fractions and compare their distance to 0 to see which one is greater. So if I go from 0 to 1/3, that's just one jump. From 0 to 2/3, it's two jumps. So I see 2/3 is further away from 0, so I know it's greater than 1/3. But I want to use the correct symbol to finish this statement. 1/3 is less than, greater than, or equal to 2/3. So I just said 2/3 is greater, so I need to use the correct symbol. 1/3, if 2/3 is greater than 1/3, that means the opposite for 1/3. 1/3 is less than 2/3, right? Because I said 2/3 is greater, so I'm going to use the less than symbol because this statement reads from the left to the right, like when we read in a book or when we read this sentence. 1/3 is less than 2/3. So let's look at this other example. So now I have two different denominators, and I'm going to show you what to do in that case. So I have 4/5 and 4/10, and I want to compare them on this number line. So I'm going to start with my fifths. So since it's fifths, I can't start in the middle, it's not an even number. I'm going to start a little bit to the right. Split it here, and then split two more times over here. And let me fix this because this doesn't look very even in my mind. Here we go, 1, 2, 3, 4, 5. Okay, I actually want to fix this again. I don't like the way it's looking. Make it a little bit more even. All right, that's better. All right, so we have 1, 2, 3, 4, 5 equal pieces, but we also want to represent tenths. So on the bottom, I'm going to represent my fifths first. So 1/5, 2/5, 3/5, 4/5, and I know that my whole is 5/5. Now I want to represent tenths, and I can do that because tenths is actually pretty easy because that just means I'm going to split all these fifths in half because tenths are twice as much as fifths, meaning they have twice as many pieces, right? So I'm going to go ahead and split all my fifths in half to make tenths. So I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. And I'm going to represent those tenths on top. So I have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 1 whole would be 10/10. So notice I did my tenths on top, my fifths on the bottom, so I can separate the two and make it easier for me to know which is which and where it goes. Also, I noticed that every 2/10 equals a fifth. 2/10 is 1/5, 4/10 is 2/5, 6/10 is 3/5, 8/10 is 4/5, and 10/10 is 5/5 or 1 whole. So I'm going to go ahead and now place these fractions on the number line. So 4/5 I see is right here. 4/5, and then I'm going to use another color for 4/10. 4/10 is here, which would be equivalent to 2/5, and 4/5 is equivalent to 8/10. So I can see that 4/5 is greater. It's further along the number line from 0. 2/5 is less space. So even though they're both 4 as their numerator, 4 jumps in tenths. Since the pieces are so much smaller, it's less than 4/5. I apologize for the texting sounds. Because 4/5, the jumps are bigger. So to answer this question, let's finally answer this. 4/5 is greater than 4/10 because I see that it's further along, so I use the greater than symbol. 4/5 is greater than 4/10. So let's try this one together. If you don't have the materials you need, please go ahead and grab them so that we can try this together. So pause now, gather your materials, and draw this number line. All right, welcome back. If you're not ready, please pause now. Draw your number line. If you don't have materials, go get your materials to be able to draw this number line so that you can solve with me. Okay, so we have our whole on our number line 0 to 1. We have fourths and eighths. Again, we have different denominators, so we're going to represent some on the bottom, some on top. So we'll start with fourths on the bottom. So to represent fourths, we're going to start in the middle because it's an even number, split it in half, and then split those halves in half. So let's go ahead and label these 1/4, 2/4, 3/4. Now to represent those eighths, and I'm going to use a different color this time so that you can see the difference. I'm going to split all these fourths in half because eighths, each eighth is half of a fourth. Are there smaller jumps or parts? So again, I'm going to label them and label it in different colors so you guys can clearly see the distinction. 1/8, 2/8. So go ahead and do what I'm doing. Let's partition this number line the same way I did. If you need more time, go ahead and pause so you can catch up. But I'm placing these eighths on the number line, counting up by eighths one by one. 6/8, 7/8. And I know my parts aren't super equal, but it's easily understood. There's no one piece that's huge while the other pieces are really small. They all look fairly even. And that's what I want. Okay, so now we can place 1/4 and 1/8 on the number line. So 1/4 I see is right here. I'm going to label it 1/4, and I see that 1/8 is right here. 1/4, 1/8. I see 1/4 is further along. Again, even though these numerators are the same, because the denominators are the same, these fractions are not equal. Fourths I see are bigger pieces than eighths, so 1/4 is greater than, again, 1/8. So I'm using the greater than symbol because again I'm reading from this way to this way. 1/4 is greater than 1/8. It's further away from 0 than 1/8 is. So each jump for an eighth is much smaller than each jump for a fourth. That's why 1/4 is greater than 1/8. So I want you to go ahead and try this last one on your own. Pause now, solve on your own, and then press play when you're ready. So again, please pause now, solve this on your own, press play when you're ready to check your work. All right, so I have 8/6 and 5/3. So I noticed right away that it's going from 1 to 2. This is a little different than what we did before, but we have dealt with improper fractions before, fractions greater than 1. So I hope we caught on to that. So I'm not starting at 0, but I'm still going to split this into thirds and eighths. So I'll start with my thirds, 2 splits to make 3 equal parts. I know 1 whole is 3/3, so this next one is going to be 4/3, 5/3, and this here would be 6/3. I can even represent this whole and make sure that I know that it's 3/3. So in a different color, I want to go ahead and write my sixths. So because 3 is half of 6, or 6 is double 3, I'm going to go ahead and split these in half, because every third is about twice as large as every sixth, because I want 6 equal pieces instead of 3 equal pieces now. So again, this is 1 whole, which means it's 6/6. I'm going to count on from there: 7/6, 8/6, 9/6, 10/6, 11/6, and 12/6 for 2 wholes. So I'm going to go ahead and label 5/3. That's right here, I see this. And then 8/6. 8/6 goes right here. I see that 8/6 is closer to 1 whole, or to 0, right, if we go back all the way, than 5/3 is. 8/6, 5/3, this is further along the number line. So 8/6 is less than 5/3. So for all of these examples today, we've been using the greater than and less than symbol. If there's ever any points where both points end up on the same exact part of the number line, then you would use the equal symbol, right? For example, if it was 6/3 and 12/6, they would both be 2 wholes, so they would be equal, right? So just keep that in mind. Just because we have less than and greater than only being used in today's lesson doesn't mean that your problem set won't have any equals. So I hope this was helpful and that you understood. I just want to go back and recap. Most of these did start with 0, but this last one that you had to do started with 1. So hope we were on our A game and noticed, hey, this doesn't start with 0. And we also noticed, hey, these fractions aren't regular fractions. They're fractions greater than 1, or improper fractions. So keep a lookout for that in your problem set as well, and keep your eyes sharp. Thank you guys. As always, you can reach out to me on Schoology or Hangouts if you have any questions. Bye.